So it's been nearly 3 months since I made the last Minecraft and Roblox video. In fact, many of you thought I gave up on the project. And now, it may look like I haven't changed much since the last video, but I promise you, there's been a lot of important functionality added, and I'm gonna go through them one by one just to get you up to speed before we add some new stuff. So first of all, you can now mine blocks, and yes, it deletes the objects above them as well. And the way this is done is using culling. So basically what that means, actually, instead of explaining what it does, let me just show you. So if I move this chunk, you can see that none of the textures that were facing a block are loaded in, and only the textures that were facing the air, the ones that we can see, were loaded in. Now also what this does is, well, there's no more black lines between blocks. And you can also see that there are actually no blocks below these blocks. But if I stand over here and mine this block, it generates new blocks around it and applies the textures where they should be. If I mine that one, that also happens, and so on. And that's what texture block culling does. We can now mine, but you still can't mine plants because I'm lazy. You may have also noticed the trees. Now, the trees have been completely reworked. They're no longer model. They are all generated using code, and if I walk here, you can see that only parts of them are generated based on what chunk is being loaded in. Now, this took forever to figure out, and many things went wrong. I mean, this is what the first tree looked like. So trees are now a thing. And number 3 is we can now save chunk differences. Now, what's a chunk difference? Basically, if you mine a block, you just created a chunk difference. So the terrain is generated on the player's computer, and the terrain is generated based on a seed, but the seed is not aware of any differences a player may have applied because it's all just mathematical randomness. So if you mine a bunch of blocks, or let's say you place a bunch of blocks, but the placement system's still not here, so don't get too excited. But let's say I mine all these blocks and I walk away. Now that chunk is despawned. So now if we walk back, so what the code is gonna do is it's gonna generate the terrain, and then it's gonna apply the differences on top of them. So as you can see, it looks exactly how we left it. And this feature will also allow for multiplayer, since all these differences are actually saved on the server. And number 4, I created a system that determines what chunks should be rendered. So first of all, in the past, the shape of the chunks loaded around you used to be a square. Then we're loading a bunch of unnecessary chunks in the corner. If we pretend that this is the player, these are all the chunks that used to be generated around the player. However, in the new system, the way it's done is like this. So we're basically eliminating all the chunks that are over here, because, well, we don't need to load them because the player can only see the minimum amount, if you know what I mean. Like, it wouldn't make sense to render it as a square. So that's number 1. And number 2 is I added a priority system, as in whatever chunk is closest to the player should be rendered first. So the way this works is we get the distance of each chunk is from the player, and whichever one is the closest, in this case it's this one, is rendered first, and then whatever is the second furthest is rendered second, and so on. So this ensures that the player will never fall off the map, because let's say a chunk is not rendered quick enough and it's not there, well, then we have an issue. But in this case, that will never be an issue. And what this also allows us to do is set crazy high chunk render distances, and as you may be able to see, it is slowly loading everything up. And this system basically just eliminates all lag spikes, because in the past, what used to essentially happen is I'd be loading and rendering every single chunk in the same frame. And the way it's working now is it only renders one chunk per like 5 frames. So there's no more lag spikes, and you can play with pretty big render distances. And one more thing, when the player dies, you are spawned back in a random position. Oh yeah, and don't worry about the unloading, it takes a second. So when you die, what basically happens is the game picks out a random rendered chunk, and if there isn't one, it's just gonna wait until there is, and then it's gonna pick the first land position, if you know what I mean. So it's just gonna check every single block until it's air, and then it's gonna teleport the player there, so you can die as much as you want, and you're gonna be back somewhere around where you died. So really, most of the stuff I've been working on are just optimization, and that would have been pretty boring to record. However, they are very essential to this game. I mean, as you can see, like, the game is literally running very smoothly with this pretty big environment just because of all these optimizations. But we've still got a lot of work left, and I want to focus on adding multiplayer to this game, which essentially just requires me to network everything. And now, since the chunk differences are stored on the server, mining blocks already works for multiplayer. However, dropped blocks don't. In fact, the dropped blocks are completely broken because I have to rework the entire system. It's like, for example, if we have a dropped block over here and we mine the block below it, it should fall. Or let's say we place a block over here, then it should get pushed up or wherever the first empty neighbor is. And items should also stack. So there's a lot we need to do there, and I think it's gonna be a pretty hard feature to add, but we gotta get it done. Will I get it done in this video? I don't know, but I'm gonna try my best. making a dropped object system is actually way harder than I expected it to be. And the first thing we gotta do is when you mine a block, as I've said before, it's gotta fall down. So I just mined a block, mine another one, and it fell down. So let me just dig out a little cave for us. And as you can see, it's all falling down. So there were like 3 different sort of scenarios we had to consider when mining blocks. And the most basic one is if you mine a block, let's say over here, and the one below it is mined, then it should drop down. That one is pretty straightforward. The second one is, let's say we mine this block, it should move all the way down instantly. It's gonna be a bit hard to see, but if I mine this, it went all the way here right away. And now I know there's no animations right now, but I've designed the system in a way that will allow me to add animations pretty simply, at least I hope. So don't worry about the animations for now. I just didn't want to waste any time on them. And another thing that I had to consider is, let's say I mine the bottom one and then I mine the top one. So if I mine the one in the middle, then the dropped object that comes out of it plus this one should both go down here. And as you can see, it did it. So I believe those are all the 3 scenarios there are, and they're all working fine and well. But now we have another bit of a problem. I mean, it's not a problem, but I personally want to improve it, which is, well, there's just too many entities in one space. So obviously there's only like 4 blocks here, so it's not that big of a deal. But let's say you toss in a stack of stones, and you're gonna have 64 individual teeny tiny blocks, all with their own textures, just taking up space in your memory. And you know, I'm a new man now. I care about optimization. When I do something, I kind of want to perfect it now. So logically, the next step is going to be to stack the items together. And the way that's going to work is we check the space. And if there's more than a certain amount, then we have to stack them up together. And one thing we have to consider is, let's say there's 65 individual stones over here. Well, then we got to create one stack, and then there's got to be one individual block. So the stack is going to be a model, and then the block is going to be a single block, and I'm going to have to store all that data in tables. Everything here is done using tables. There's no physics here. And I mean, this looks already way better than just having a bunch of blocks just floating around. And here I am once again. I did in fact manage to get the stacked objects to work. And for the items to stack, well, they've got to be of the same kind. So dirt and stone doesn't stack, obviously. We just gotta keep that in mind. And now that I mined another block, as you can see, this is actually a model that I've created. And if I mine another block, it didn't change the way it looks. If we keep mining, it's just gonna look like that. And honestly, I don't want it to be just 2. I feel like it would make more sense if it's like 4, like 3 or 4. So then like if you keep mining, it's just gonna keep adding individual blocks until you reach, as I said, 3 or 4. And then it starts to look like a stacked object. But now when I mine a whole bunch of blocks, they're all just stacking. And oh wait, why are these floating? Oh no. Anyway, so I'll be right back. Why is this happening? After quite a bit of debugging and reworking certain systems, I think everything's operational now. So of course, when you mine, the blocks are gonna stack. We know that already. So let's just mine this out. And then what we're gonna do is we're just gonna walk away from the chunk so it deloads. And let's see if it stays the same and not have any blocks floating. And as you can see, it has unrendered because we can't see it over here. And if we walk in its direction, it should re-render. There we go. And as far as I can tell, I think everything looks right here. So now I think the next step should be picking up blocks. I honestly don't even care that much about animating them for now, because like it doesn't look bad in my opinion just having them sitting there. But I do think I should make some sort of like dropping animation. But you know, I'll save that for the end. So this is going to be my multiplayer test, and I believe I just got the dropped objects to work in multiplayer. And mining also works, however, I'm still lacking a few things like the mining, like particle effects around the block. But if I break this block right here, as you can see, the environment around it changes and a block is dropped. Now if I mine the one underneath, they all move down. See, the issue is I literally for some reason cannot move the camera while I have 2 like clients open. But if you can see there, like all the way at the bottom, you can see a stack. Or if I do it over here, there we go. Yeah, I don't know why I didn't do that. Okay, so look, I'm mining everything and it's updating accordingly. Okay, wait, it shouldn't be displaying these blocks out here because those chunks are now rendered. I must fix that. But anyways, a lot of progress is being done. So there are a few more things I want to add before I finish this recording up. And obviously number 1 is going to be picking up objects. Although I may not do this first because I kind of think it's a bit boring. But the other thing that I want to do is I want to modify my terrain generation system so that it allows for more crazy terrain like this. Because at the moment I feel like it's a bit basic. There's obviously no cliffs, there's not even any caves. I'm not sure if I'm gonna do caves yet, but the reason it is like this is because I'm using 2D noise, and all that does is determine the height of every position of every block. But we're gonna have to use 3D noise, create cliffs and crazy terrain. I kind of did something that's very cool with the terrain generation. Let me just show you this. Just look at this. Look at this beauty. What? What? How did I make this? This looks insane. Like there's a whole tunnel and like a bridge connecting land masses. There's cliffs and overhangs and yeah, that's about it. I feel like we're getting closer and closer to the actual Minecraft terrain. It's still nowhere near as complex, but like, oh my god, like I want to explore this now. Like the way it used to look before was very generic because the only values I was changing was the Y height, which is like the height of the surface level, and that was it. But if you look over here, there is no set surface level because there's some blocks up here and there's blocks up here. So there's like 2 surface levels, if you know what I mean. So you may be wondering how this is done. And basically, instead of using 2D Perlin noise to determine where the surface level should be, I'm using 3D noise to determine what should be air and what should be a block. And the closer this value gets to the actual base surface level, okay, I don't know if I can even explain this, it just doesn't make sense. But basically math is beautiful and sometimes confusing. So with the way the code works right now, I'm actually going to be able to create biomes. Oh my god, this is actually beautiful. What am I looking at? Okay, what is going on with that tree? So basically what's happening is the first step of the code is to determine where there should be a block and where there should be air. And where there should be a block, I just set it to stone. And then the second step is, well, to pick out what biome it should be. And, well, of course, in this case, I only have this singular one. I don't even know what it's called, honestly. But then what we do is replace the top surface layers with dirt and grass blocks. Well, obviously, this can be changed to whatever we want. This could be sand. It could be snowy grass blocks. But I'm going to save biomes for a future video, just because I want to perfect this terrain first of all, and I think we're getting there. And of course the dropped blocks still work. They're all stacking over here, all nice and beautiful. You still can't pick them up though because I'm lazy. Picking blocks is going to be pretty easy to do. You just got to check the distance that the player is from the block, but I think the important part is optimizing it. Like if a block is dropped all the way there, I obviously shouldn't be checking if the player is close to it. So I'll just check the blocks that are around the chunk that the player is in, if that makes sense, and around the Y height. I'm actually having so much fun just exploring my own environment. And one thing I'm actually pretty excited to add is ores. I'm not 100% sure how to do it, but that's gonna be pretty cool. And oh my god, this is so nice. Yeah, I'm not gonna lie, I think I should probably stop running and get back to work. So I'm using Trello to track what I should add to the game. And so as you can see, I'm working on the dropped blocks. And when a block is broken, I believe I should do the particle effects. And I also gotta get placing blocks done, caves. And the way caves is done is actually pretty similar to how I'm generating the terrain at the moment, which is by using 3D noise. And we also use something called Perlin worms, which looks a bit like this. So we use the Perlin worms to generate like the tunnels, and then we can use 3D Perlin to generate like the big caves. And once we get that done, plus the ores, plus a death screen, and just a little menu, the game should be ready for version 0.0. I'm probably not going to make it public when I reach the end of version 0.0 just because I'm afraid this game's going to get taken down or my account gets deleted. So in a future version, I'm just going to adapt everything to be more of my style and obviously not use any copyrighted assets. And then I'll make it public. But like, wow, this is just so beautiful. I feel like everything's starting to come together. So like if I go over here and mine these blocks up here, there may be no animation, but all the dropped blocks are actually down there. And oh wait, I need to make the dropped blocks ignore plants. That is not good. And see, that's why we test. So there is one thing I sort of forgot to show off. That's because there's really no way to test it unless I'm using like print statements, which is crafting. The logic for crafting now works even though there's no crafting table. I can simply pass my inputs to this function over here. So in this example, the X represents nothing. That's just going to be an empty slot. And then next to it, we have the oak wood, and same thing with the bottom row. This would be crafted in like your inventory. So another way to imagine this is imagine these are empty and there's wood planks here. And as you can see, it returns the result, which is a stick. Now in the next example, I place the wood planks in the opposite side. So imagine these two have wood planks and these two are empty, and I got the same result. And the logic behind this is actually pretty weird, and that's mainly because I didn't want to have to save every single possible formula. In fact, the way that they are saved is pretty weird. I first have a table that has the number of rows, and then I have a table that has the number of columns. So based on whatever I'm given, so let's say we have wood planks over here. So what my code would do is shrink this down to where there are actual items. So this would be a 2x1 because we have 2 rows and 1 column in the blocks. So what the code will do is after it shrinks it down, it goes to the 2 because that's the number of rows, then 1, which is the number of columns, and then it's going to return all the recipes there are and the results. So number 1, we have a stick, and we also have a torch. Then it checks if the recipe matches the recipe. That's the way it works. This way I don't have to save a whole bunch of possible formulas. Like imagine this was a normal size crafting table and a player placed down a wood log literally anywhere. Then I would have to return a wooden plank, but then I'm gonna have to store 9 separate recipes just for wooden planks. And the last couple of videos, lots of you guys have asked me to show you some of the code or go more in depth into the technical side, but at the same time I know many of you guys don't even want that because it does sound a little bit boring. But if you want the technical stuff, if you want to understand how all of this works, then now's the time. The most important script I have is the chunk loading module script, and that's because this is a script that determines what should be loaded and what should be rendered. Same thing's true for unloaded and unrendered, and this is sort of the root of every other script. By every other script, I mean the dropped object and the world generation. So every fourth frame, I mean this could be any number we want, I find what chunks to load, and the way that's done is I just find like a circular radius of all the chunks that are around the player, and then I load those chunks. And what that basically means, I'm just calling this function that just goes through all the chunks there are that we want to load, and then it calls the appropriate functions in other module scripts. And then the same thing is done for a rendering. However, as I said before, there is a render priority system, and that's literally just done by finding the closest one to the player, and this is why math is important. And after the priority is reordered, I simply do the same exact thing I did to the load chunks function, and I pass it over to the render chunks, and then I just call the appropriate function. And since the first thing that's done for world generation is loading, the way that's done is I create a 3D table that's just air, and then I fill in the table with any preloaded data. And what that basically means is if I generated a tree on a neighboring chunk and some of the leaves had crossed over into this chunk, then I just fill them into the table. And then afterwards I generate the terrain, which is all just going to be stone, and that basically just shapes how the terrain is going to look. And that's where we have all the cool mountains and cliffs. And then using that terrain, I fill in the surface layer, which is obviously dependent on the biome, but for us it's just going to be grass blocks and dirt. And then lastly, I just fill in the top with flowers, trees, and so on. One thing you may have noticed is not here is the chunk differences. And why did that just happen? And I do that using a remote event, just because if it's a remote function, then I'm going to have to wait until the server returns something, which would slow down the chunk generation by a lot, just because I have to wait for the server every single time, which depends on your internet latency. So I just fire this event. Then on the server side, what's going on is I'm literally just returning the values inside of a table if they exist. And once the server fires back with all that difference information, I just go through every single one of them. I get the block name, the world position, I convert it into a chunk position, and lots of things are being done here. So if the chunk is loaded, then I just update my loaded chunks data, which is the 3D table I was talking about. But I have two tables. One of them is the loaded chunks, which is just the name of the blocks and where they should be. And then I also have another table for the rendered chunks, which is the same thing, but instead of the block name, I store the actual block that is in the world. And then a whole bunch of logic is being done here. I'm actually not even 100% sure what I'm doing, but I mean, this is a huge function. So that's a bit messy, but if we look at the terrain generation, you can see just how short the function really is. I mean, this is like 25 lines of code. So really, all the terrain generation that's being done is literally just a numbers game. There's just a bunch of numbers being toyed around with until you get a result that you like. So that's really how the terrain is working at the moment. It's nothing too complicated, but it's just important to keep your code organized and readable. And it really wasn't in the last video, which is why I literally just redid everything. So that's gonna be all in today's video. It's kind of cool seeing how this game went from something that I thought is like not really possible for me to achieve, to figure out some very basic things, to now like having gone way further than I thought I ever would. And I'm excited to see what I'm gonna do in the next video, because even I don't know, maybe caves and water. Okay, bye.